to get your code that you've written to run on the ATtiny85, you do have to make a couple of changes. Now, there are two ways to do this, right? The first way, and that's the way I'm going to show you in this video, is you can take this code that you're going to be provided with, and you can edit that and basically put the functions from your code into that and basically use that. That's going to be the easiest. You can, of course, do the opposite. You can take this code and take the bits that you need, the useful bits out, and put it into your code. It will depend on how comfortable you are with working with the code and how much you've sort of retained, which option you choose. So first option, you're going to take your code and you're going to put it into this code that you're being provided with. So let me take you through a few things that you need to change. So first things first, on the Arduino, we were using pins, I think it was 3, 5, and 6. But on the ATtiny, because it's built into a board in a specific way, you've got to use certain pins. So red is pin 0, green is pin 1, blue is pin 4. So those have just been changed to 0, 1, and 4. The sensor pin, that's our potentiometer, that's plugged into pin 2, which you can get to by just referring to it as A1. So if you just have A1, right, that works. So those are simple. The not so simple bit is that there is a lot of sort of difficult to interpret code here to get the button interrupt working. So if you recall, a button interrupt is something that runs in the background, and anytime you push a button, it's going to do something that's associated with that interrupt, which is really handy. So this first bit here, right, that states that our interrupt pin is on pin 3 of the ATtiny. We've got a delay in here for bounciness, and we've got a couple of other variables about what happens with our interrupt. We also, in our void setup, we have this line here. So we're enabling our interrupt. And then we have this function here, right, which is sort of enabling our interrupt and sort of setting what happens, what the interrupt pin does. We've got this little snippet here. And then these are just my functions for what my code does. So this is a fade. So I've got my void LED fade. So that's my function called LED fade. And all it does is it fades up red and down red and up green and down green and up blue and down blue. You can have a look at that. And here's my flash. So those are just my sort of functions for the behavior of my edge lit piece. And then down here in void loop, we have this if interrupt flag. So basically, if the button is pressed, if the interrupt happens, then we're going to increment that button count. And then we've got a little delay to bounce. That's just to stop us getting double presses and things like that. And we set the interrupt flag to false. You don't really need to know what that means. And then we just have a little if statement here to control what our button count goes to. So mine at the moment is set up so that if the button count gets higher than 1, it sets it back to 0. So I only have two options, right? My button count can be 0 or it can be 1. The moment it goes to 2, it's going to go back to 0. I've got the code here that reads my potentiometer and maps it to, for me, some delay values or delay time. And then I just have if the button count equals 0, do this function, and else if the button count equals 1, do this function. Now I could change this to 2, and then I'd have three options, 0, 1, and 2, and I could have another else if statement here if I had more behaviors, right? More things that my code did. Now, in this as well, I like to have functions in here because I just think it's nice and neat, but you could also just hard code in here what it did if that's where you got to with your project. So this is the easier option by far, is to take this code, right? And what you could do with that is you could just go, okay, I didn't do fades, I did changing colors. And so I could go here, I could get rid of this function, right? Get rid of that. I could put in a new function that's called color change. And then I could just say, if my button count is 0, hey, I'm going to do the color change function. That's it. That's how to change that code. Now, put your chip back in the programmer. Click the little lever. plug it back into your computer. Jump back over to your IDE, go to Tools, make sure everything still says what it's supposed to, so ATtiny under Board, port's got a tick next to it, we've got the ATtiny 85 selected here under Processor, and Programmer is Arduino as ISP. And then we can go Sketch, Upload using Programmer, cross your fingers and hold your toes. There we go, that's done uploading. So now we can pull that chip out and we can put it into our PCB and see if it works. So you've got your own code on this ATtiny now. And so what you're going to do is you're going to take your PCB with the USB cable connected to it, and you're going to seat that socket in there like that. Now you've already confirmed, hopefully, that your PCB is in good nick, so you can just plug it in to a computer and you can turn it on. So what you need to do is you need to test that it behaves like it's supposed to. So for me, if I change this potentiometer, I should be able to change the flash speed, and if I push this button, then I should get a fade up and a fade down. And the reason that I'm getting this really odd flickering is because of the frame rate of the camera. Looking at it with the naked eye, all you can see is a fade up and a fade down. So that works. Now if yours doesn't work, you're going to have to do a little bit of troubleshooting of your code. But if it does, unplug the USB port, and what you're going to need to do is figure out how to get it into this box. So in order to get it into the box, you're going to have to take that USB cable out, and you're going to need one of these little nuts that fits onto this potentiometer. So take a screwdriver, a flat blade, and just undo both of those screw terminals. That'll let you pull that USB out. See, I'm having a little trouble with the red one, just back that out a bit further, and eventually I just gave it a bit more of a pull, and then had to fold that wire back over. So this is the box. Take the lid off it, and the very first thing you need to do is you need to take that USB cable and feed it through this hole in the left-hand side of the box. Right? If you don't feed it through, you're never going to get that PCB into the box. So shove the box down the line, and then what you want to do is you want to put those positive and negative wires back into that screw terminal. And I've learned my lesson about trying to get more than one of those in. So nip up my positive and my negative. Again, finger tight. If you put all your strength into this, you will definitely destroy that screw terminal. Okay, now that that's attached, slide that USB cable back through that hole, and then on an angle, line that potentiometer up with the big hole and the button with the small hole, and then fit this nut over the end of the potentiometer to secure everything down. Once that's nipped up, what you're going to want to do is make sure that that USB cable doesn't go anywhere, right? If you just leave that flapping like that, it's going to be really fragile and eventually it'll break. So what you need to do, go over to where the glue guns are and put a generous dob of glue where that cable comes through the wall of the box. And then let that cool down. It's going to take a minute or two. Right? This is on 500 times speed, and it still feels like it's taking a long time. It takes a while. Let it cool down. It'll go kind of cloudy. You can move the wires around if you want to. Right. There we go. Okay, we're finally cool. So now what we need to do is get this LED strip down into position. Now, if you did a really good job of soldering this, then you're going to have 7 LEDs on this strip, which is one too many. So you're going to have to go and chop one off. So cut it just between the terminals and the resistor on the 6th lead. There you go. So now that's the right length. So what you need to do is peel this sticky backing off and watch me fumble with this. There we go. So peel all that sticky backing off. It'll probably be stuck a little bit under your heat shrink, but you can just yank it out of there. Right. And then you want to stick that LED strip down in that recess there for it. And you'll need a pencil or a screwdriver or whatever just to poke it down to get it to stick. And just push that cable down out of the way. If you need to, I guess you could fix it down with a dab of hot glue, but you probably won't need to. And then fit the top to the box. And then to lock the box top on, you're going to need 4 bolts and 4 nuts. And once you've got your bolts and your nuts, you're going to want to just thread the bolt into the nut like that. And then the way that these work, these are called T-slots. And so what you do is you put your nut in there, and then you take a screwdriver, and what you can do is you can just tighten that down gently, and that will lock that box top against the slot and the nut and hold that all together. So you need to do that with all 4 corners to assemble this box. So that's done, except for the insert and the potentiometer knob.